Hi everyone. Today's objective is to identify the axis of symmetry and the vertex of a quadratic equation given multiple representations. So we have talked about the axis of symmetry and the vertex in the beginning of the unit, but we only talked about looking at them on a graph. Today we're going to talk about how to find the axis of symmetry given different representations of a quadratic equation. So we're going to start by looking at a graph to refresh our memory about what the axis of symmetry is. And the axis of symmetry is the vertical line that divides a parabola into two congruent and symmetrical halves. Okay, so if we take a look at the first example, we have our parabola on the graph. And if I draw a line through the center of it, I can split this parabola into two symmetrical halves. Okay, so that line is our axis of symmetry. Okay, so now we need to write an equation to represent that line. Well, this line passes through the point x equals 1. The equation of this line is x equals 1. Okay, so a few things. The axis of symmetry always passes through the vertex. So remember, the vertex is that minimum or maximum point right here on the graph. Okay, sometimes we call it the turning point because it's where the parabola starts to change direction. So as we move from left to right, the parabola here decreases until it hits the vertex or the turning point, and then it starts increasing. So that's our turning point right there. And notice the axis of symmetry passes through the vertex. Okay, the x-coordinate of the vertex is the equation of the axis of symmetry of the parabola. Okay, so here x equals 1 is the equation for the axis of symmetry. It's also the x-coordinate of our vertex. They will always be the same. Okay, and here we have a formula to find the axis of symmetry if we're given an equation, and we'll talk about that in a minute. Okay, so now we're going to write the ordered pair that represents the vertex. Okay, so our vertex is always written as an ordered pair. So if I take a look at the turning point or the vertex here, I know the coordinates are 1, 1, 2. And again, notice that the x-coordinate of the vertex is the same thing as the equation of the axis of symmetry. Okay, so now let's say we're given an equation for a quadratic function. So for example, f of x equals x squared minus 2x minus 3. So we could graph this. We could plug this into our calculator as y equals x squared minus 2x minus 3. And you could take a look at your table and find the turning point. But we do have a formula to find the axis of symmetry algebraically. So the formula is x equals negative b over 2a. So I'm going to write the formula x equals negative b over 2a. So first we need to identify what a and b are. So a is the coefficient of x squared, which is 1. And b, the coefficient of x, which in this case is negative 2. So now I'm going to plug in, and I get x equals negative 2, negative b, over 2 times a, which in this case is 1. And then just evaluate, negative 2 is positive 2 over 2, which equals 1. So notice that for the axis of symmetry, it's x equals 1 because we are writing the equation of that vertical line. So x equals 1 is the vertical line that goes through that parabola. Okay? Now, how can we find the vertex? So remember that we just discussed that the vertex has the x value of the axis of symmetry. So I know that my vertex is going to occur when x equals 1, and I just need to find the y value. Remember that the y value is just our output for this function. So all I have to do is use my equation and substitute in x equals 1 into my equation. So I get 1 squared minus 2 times 1 minus 3. Okay, you can just plug that into your calculator. All right. Or you can solve it by hand. I get 1 minus 2 minus 3, which is negative 6. I'm sorry, negative 4. So my vertex is 1, negative 4. Okay, now keep in mind, if your x value is negative when you're substituting, remember to put the number in parentheses, especially for this exponent, okay, and definitely when you plug into your calculator. Also, your axis of symmetry doesn't have to be a whole number. It could be a fraction. That just means that the vertex doesn't occur when x is a whole number. It occurs at a decimal value, and that's totally fine. Okay, now go ahead and try the you-try problems on your own.